Assalamualaikum warahmatullahi wabarakatuh, and have a nice day to our supervisor, Dr. Rafidah binti Ngadengon, alias Ngadungon. Also our panel, Prof. Madya TS Dr. Elmy Johana binti Mohamad, and Dr. Herdawatie binti Abdul Kadir. My name is Mohamad Akmal bin Zaiton, Nomor Matrix DE180007, will present for the final year project 1. That the title is Identification and Control of Direct Current Motor using Fuzzy Logic Controller. So we look at the project background. System identification is a methodology for developing mathematical model of dynamic system from experimental data by estimating the values of adjustable parameter in a given model structure using measurement of system input-output signals. Fuzzy logic controller are used to control the speed of the DC motor. PIDD controller requires a mathematical model of the system, whereas fuzzy logic controller rely on experience gained through rule-based knowledge. It will be demonstrated in this thesis how fuzzy logic provide a mechanism for representing and implementing information about how to govern a process. Indeed, design your own fuzzy controller for a DC motor and simulating the fuzzy control system to evaluate its performance is the greater method to truly understand fuzzy control. Next, we look at the problem statement. System identification can measure the input and output signal from our system in time or frequency domain. System identification is a build for mathematical model of dynamic system. Then fuzzy logic algorithm help to solve a problem after considering all available data. Then it takes the best possible decision for the given the input. Next is the objective. The objective number 1 is to integrate hardware using Arduino Mega, and then to obtain mathematical model of DC motor using system identification, and to design and analyze fuzzy logic controller that controls speed of DC motor. So the scope of work of this project is, it is focused on the encoder sensor used to measure the speed of motor. Motor driver L298N will use for control DC encoder motor, and the microcontroller that will be used in this project is Arduino Mega 2560. So next is the methodology. The methodology of this project is also contains a design flow description, a common flowchart project, hardware and system software explanation. In this chapter, method and alternative that have been used for design the control are discussed and explained in detail, including the step for getting the model for the position of hardware configuration, implementation of the control on Arduino Mega, system identification, and fuzzy logic controller. So this is the flowchart for the fully project. We start and then design and development hardware and software. So for the hardware, use microprocessor Arduino Mega 2560, motor driver L298N, and DC encoder motor. So for the software, use MATLAB to get the data and then system identification and get the transfer function. From the transfer function, we'll get the mathematical model, and then we'll use for the fuzzy logic controller, analyze and test, and the project will end. So this is a hardware development, as you can look at here. Arduino Mega as a microprocessor, microcontroller, and then L298N motor driver to control the DC encoder motor. So the DC encoder motor have an encoder to get the data. Then we look at the first thing for the hardware is Arduino. Arduino is a component that design and manufacture single board microcontroller and micro kits for the development of digital gadget and interfacing object capable of sensing and controlling physical items. The board is outfitted with digital and analog input and output pin. Next is motor driver L298N. Motor driver is a dual bridge motor driver that can control the speed and direction of two DC motor at the same time. The module can power DC motor with voltage range from 5 volt until 35 volt and peak current of up to 2 ampere. The model features 2 screw terminal blocks for motor A and motor B, as well as another screw terminal block for the ground pin. the VCC for the motor, and a 5-watt pin that may be used as an input and output. So this is DC encoder motor. The DC encoder motor is an electrical machine that transforms electrical energy into mechanical energy. The electrical motor uses direct current to convert electrical power into mechanical rotation. An encoder is an electromechanical device that generates an electric signal that may be used to regulate speed and or position. Encoder convert mechanical motion into an electrical signal that the control system used to monitor certain characteristics of the application and make change as need to keep the machine running as instead. So for the MATLAB software, must install Arduino support package for hardware for use at the Simulink and design the Simulink block for the get the input and output of the data. So next is system identification toolbox. Must install in MATLAB for use to get the transfer function. Okay, next is preliminary result. So this is my preliminary result. After get the data for the input as a voltage and output as a rotation or speed motor RPM. A common window MATLAB, type input and output to get the data into workplace. So at the common window must type input, same as out.v and 2. So output, same as out.y2. So the workspace will be saved as input and output. And then this is my hardware. So at the system identification toolbox, insert the data for input and output. So this is the data, input and the output. And then data name, we decide, and start time and sample time, and then we import. So next is insert my data to workplace and select remove means to get the better result. For this transfer function, we must get the best fit after transfer function. So to get the better result, I use a remove means to get the best fits. And then after new data added to data view, drag new data to working data and select transfer function model. And then this one, my data after remove mean, drag this one into the working data and then select transfer function models. So insert number of poles and number of zero for transfer function to get best fit. So for this project, I set number of pole is 3 and number of zero is 2. And then estimate, and the model output will be get the new data. So this is my best fit, 95.6%. So the best fit is highest. And then click new data in model views. New tab will appear the value of transfer function. This transfer function will be used for design fuzzy logic controller. This is my new data and for the use in fuzzy logic controller. This is the transfer function. So in the conclusion, according to the previous chapter, the system identification was successfully developed in order to obtain the transfer function, and the best fit obtained was 95.6%. The design of the fuzzy logic controller is also critical to the project. Aside from that, the Arduino Mega board is essential in the data acquisition system. The L298N is linked to a fuzzy logic controller via a MATLAB Simulink block, and an Arduino Mega board serves as an interface between the controller and the MATLAB Simulink block. So that's all from this presentation for final year project 1. Thank you and have a nice day.